Lesson 64, Identify, Write, and Graph Inverse Variations. So we want to remember direct variation. We've talked about this before. Direct variation is points or a line that goes through the origin or is aligned with the origin. It has the equation y equals kx, where k is a constant. Or you could say k equals y divided by x, and we sometimes call that the slope. So it's a line. It has a slope, but does not, the y-intercept will be 0, so you won't see a plus b there. Now, inverse variation has more of a curvy shape. So if you were to draw a picture of inverse variation, it's going to kind of look like this. So now the equation for this one is y equals k divided by x. Or if we multiply both sides by by x, we get k equals x times y. So basically when you multiply both values, you're going to get the same constant. So I want to think about rectangles right now, okay? So we're just thinking about a rectangle. We want the area of this rectangle to always be 16. So when we find the area, we're going to have length, or width is going to be x, length is going to be y, and the area is when we multiply the two together. So we want our area to be 16. So we could have a width of 1 and a length of 16. We could have a width of 2 and a length of 8. That'll give us an area of 16. How about 4 and 4? That'll be a square with area of 16. We could have, well, would it make sense to make the width 8 and the length 2? Because that's going to still be, the width is 2 and the length is 8. So anyway, we could switch it and say, well, if x is 8, then y has to be 2. And if x is 16, y has to be 1. So notice this would give an inverse variation because when we multiply x and y, we get the same number every time. So what we found was x times y equals 16. And if we solve for y here, we get y equals 16 over x. And that would be our inverse variation equation. Now, if you know two solutions, and if you have 2 points, x1, y1, and point x2, y2, and you want to know, well, let's say you know there are solutions to an inverse variation. Then we could say that when we multiply the x and y's together of one point, it has to equal the multiplication, the x and y of the second point multiplied together. So it's a really good way to find a missing number in a set of points. So let's say if here's an example. If a function has inverse variation and goes through the point 3, 4 and through the point 2y, what is y? So we can multiply 3 and 4, and that has to equal 2 times y. So we have 12 equals 2y, which gives us that y will be 6. And that would be the answer to that question. Let's do another example. If y varies inversely as x, and y equals 3 when x equals 12. Then find x when y equals 9. If you want, we could write these as 2 points. So we have x, y, we have 12, 3, and the other one would be, we don't know x, so it would be x, 9. So it's just like the problem above. We just have to multiply 12 times 3, and that needs to equal 9 times x. Well, 12 times 3 is 36, which is 9 times 4. So x would be 4. So when it says y varies inversely as x, that's just an inverse variation where the x times the y is going to give us a constant k for every point in that function. So let's say that we have, let's see. Oh, okay. Let's write the inverse. Here's another example. So we're going to write the inverse variation relating x and y when y equals 8 and x equals 3. Then we want to graph. Okay, so we know we can find k. K just equals x times y. So we have 8 times 3. Okay, so let's see, x was 3, y was 8. So k equals 24. Now it's inverse, so we're going to write our equation y equals k over x. So it's 24 over x. And this is what we're going to graph. So we find k, which we did, write the equation. So here we better write what we did. Find k, that's step 1. 2, write the equation. Okay, now we are going to plug in some points for x and y. We can have positives and negatives, but we know that x times y has to equal 24. So we can look at some numbers that multiply to get 24. So if x is 4, y is 6. When x is 3, y is 8. When x is 6, y is 4. And what about negatives? So we could do the same thing, and x times y has to equal 24. So how about negative 4, negative 6, and negative 3, negative 8, and negative 6, and negative 4. Okay, we already know the graph looks like that one little kind of curvy thing. So we're going to graph this. We have to go to 8, and it's negative 8. I'm not spreading them out very equally. Maybe you guys can do better. Okay, so we're going to graph these points. 4, 6, 4 up 6, 3, 8, and 6, 4. So it's going to be kind of curvy up here in this area, like that. And then we have negative 4, negative 6, negative 3, negative 8, and negative 6, and negative 4. So it's going to be curvy in this quadrant 3 here. And that's what this graph would look like. So we wrote the equation and we graphed it. Okay, so here's one thing just for your information. When k is positive, okay, like the 24 up above, the graph is similar to this, where we have in the first and third quadrant. Okay. Now when k is negative, the graph is similar to this picture. We'll have those curvy graphs in the second and fourth quadrant. It's going to kind of look like this. And that's the end of the lesson.